All right. Hello, everyone. We're going to get started. Thanks for coming out to our lecture. Today, we're going to be talking about pathfinding. All right. And the things we're going to go over today is first, we're just going to look at why a good pathfinding algorithm is important for the success of your bot. We're going to go over a few algorithms for pathfinding and look at like the trade-offs of each one and look at some issues that you could run into. And then we're going to do some live coding and implement 3 different types of the bug nav algorithm. Okay, so first of all, if you watched the lecture on Wednesday, or if you've been working on making a bot, maybe you've already tried out some simple pathfinding strategies. And if you simply just like have your bot walk towards whatever location it's trying to go to, that's not going to work very well because you'll run into walls, obviously. And so on Wednesday, like a slightly smarter version that we implemented is we had it so that if a bot can no longer continue in like the direction it wants to go in, then it just moves randomly. But as you saw, that still doesn't work great because then they just kind of jiggle around and don't get to where they're trying to go.
Yeah, so what options do we have? Should we panic if we run into a lot of walls? Probably not. Okay, maybe we should. Should we just freeze in place and just not go anywhere and let the other team take all our flags? Also, probably not. Should we move around randomly? You can actually do that, but it might take you a very long time if you have an area that's kind of enclosed off by walls on 3 sides. So how about we try some pathfinding?
All right, so basically pathfinding algorithms are just ways to find the shortest path between 2 points for your bot. And we're going to go through some common algorithms.
So one common algorithm that you might have heard of if you've ever taken an algorithms class is breadth first search. And as this animation shows, all it does is you start on a point, it just tries searching every single point that's like next to that point and just keeps going until it searches the entire thing. Another pathfinding algorithm you might have heard of is A star search, which is a slightly smarter one. And what it does is for every point, it calculates how much cost it took to get to that point, for example, the distance, and how much cost it thinks it will take to get from that point to the end point. And then it will look at the one with like the shortest sum of the previous cost plus the estimated cost, and it will choose that one to keep going forward.
All right, so there's some trade-offs with these algorithms though. For both A star and BFS, they tend to be very bytecode heavy. So it might be the case that it's not possible for your bot to do all those computations in one turn. And in that case, your bot might just be sitting around like waiting for the computation to finish and potentially wasting turns that it could have used to get to its goal if it just immediately started using a simpler pathfinding algorithm. And also these algorithms tend to rely on knowledge of like the global board state. And in Battlecode, we have like the vision radius of each bot. And so you tend to only know about the walls that are very near your bot. So it's very possible to overcome these issues with having some kind of like distributed pathfinding algorithms or taking advantage of communication to get a more complete map of what the entire board looks like. But even so, simpler pathfinding algorithms tend to be very effective. And even if you're going to use like BFS A star, it's still very important to have some simpler algorithms like BugNav that we're going to show you to fall back on in the cases where those don't work.
All right, so now we're going to talk about BugNav. And as the name suggests, this is kind of based off how bugs navigate. So it only uses local knowledge because a bug does not have the view of the entire world. And the most simple BugNav algorithm, which we're going to call bug 0, is you try to go to the target, you see that you run into a wall, so then you just follow the wall until you can keep going to the target. Let's see how this could be implemented in code. Okay. VS Code. So here we have the lecture robot player that we've had for, is it the lecture robot? Yeah, that we've previously seen 2 days ago. And also yesterday if you were at the Git lecture. And what I'm going to do is quickly just add some code so that it only spawns if like it's the first bot to spawn and afterwards it does not spawn. If the shared array is 0, it's just going to put its own ID into there. 0 and then it will only spawn if it is, if its ID is in the shared array. Very nice. So now we only have one bot that's going to spawn, so we can more carefully observe the behaviors of this one bot. So I'm going to make a new file that specifically handles the path. Actually, I probably don't need it. I could just write the pathfinding algorithm in here. So at the end here, we're going to add a new public static void. Bugnav0. And it's going to take in the robot controller RC, as well as the map location that it wants to go to. We'll call it destination. So does everyone remember what the first step in bugnav is going to be if it's like in an empty area with nothing around? So it's going to try to move towards the target. So we can set a direction. We'll call it direction dir is equal to, I think I call it bug dir, is going to be equal to rc dot get, I think it's rc dot get location, and then dot direction to destination. So now we're going to be like, if rc dot can move in this direction, which would be the best, it would then try to move in this direction. However, if it cannot, then we have to do some other things. We have oh, yeah. Yeah, thank you. So if not in this case, we're going to try to have it go towards the left. So actually, yeah, we're going to have to try to go towards the left. So, but we don't know how many times it needs to turn towards the left before it finds somewhere where it can go forward. So we're going to do a for loop. Oh my God. So we're going to say if rc dot can move in bug dir, yeah, then it's going to then try to move in that direction. And it's going to set, but if not, and then once it does this, it should break because then we don't want to keep going in the for loop. If not, it should set bugdir to bugdir dot rotate left. And now this just means that if it can't go forward, it's going to try its best to like try to go left. And then if it can go left, it'll just keep following left until it's able to then go back to the destination. So we go into main phase here. Yeah, main phase. See, oh no, actually we just want to go to robot player because right now we don't want it to be going, we don't really want it to be doing main phase or setup because we just want to see the pathfinding algorithm. So I'll just quickly comment those out. So I'm going to make a map location destination is equal to new map location. We're going to say 6, in this case. And then we're going to do pathfind dot bugnav0 using RC and destination. And then let's see how this one runs. See where is we have a simple place that could use pathfinding, and then we're just going to run both lecture players. Okay. So you can see, okay, that one is kind of stuck because of the wall there, but if we slow down and go back, see, decrease speed, we'll see that the brown duck spawns and immediately starts trying to follow this path. And then once it follows it all the way until it can see the crumb, it heads straight to the crumb, and then it gets there. And this white duck, once the wall clears, yeah, it ends up there too. But it can't go there because the brown duck is there, so it's just stuck forever. So this is bugnav0. But can you guys think of a possible problem with bugnav0? Well, there's this really specific case, actually probably a couple of specific cases where you can see here, if you're having a left following algorithm, it's just gonna keep trying to go left and there's something blocking it. So it's just gonna go around forever, which doesn't seem like what we wanted to do, right? So instead we have to do bug nav 1, where what it does is it sort of remembers the obstacle and it just traces the obstacle. And once it hits the closest location to the target again, it then continues to go forward and then traces the other one until it finds the closest location and then it goes forward again. So to implement this one is slightly more complicated. We're going to have to add some states. So in case you don't know, a state is just something that tells a robot what stage is it in, how should it behave. So we're going to set private int bug state. And I'll start by setting it to 0. This will be like the default, like I'm heading towards a target. And when it's 1, 0 is head to target, and then 1 is circle obstacle. And also something that we need is we need to be able to keep track of where the closest location to the obstacle is. So we're going to have a private map location as well. And we can call this closest obstacle. I don't know why I keep trying to autocorrect everything with location, but I probably said to no to begin with. And we also need to be able to keep track of how close this closest obstacle is. And this will also just be, you can just set to some really large number that's too large to be any distance on the map. And finally, for this version, you actually wanted to remember what direction it was going in previously, especially if you're on bug state 1. So we're gonna finally have a private direction and we'll call it bugdir again. And now something that might be helpful is when you just get started, you might want to initialize all of these variables. So at least you want to initialize bug state 0. So I'm just going to add a public static void reset, set bug. And then it's just going to set the bug state. It's just going to set all these things. That way, if you run bug state once and then you want to run it again, you can start from like a clean slate. Oh yeah, static. All right, so now we take a look at, did we do this in, oh, oops, this should have been in Pathfind. So I'm just going to copy and paste that there. Pathfind is here. And then I'll start a bug nav 1. Okay, so we want to start by checking if bug state is equal to 0, because if it's equal to 0, then we'll just be trying to head towards the target location. So if rc dot, oh yeah, we need to get the target location, of course. So if it's 0, then we're going to try to head towards this bugdir and move bugdir. Move. But if we can't move bugdir, then we know we're kind of in trouble because that means there's an obstacle in front of us. So now we want to circle that obstacle. So we're going to start by setting bug state equal to 1 because that tells us we're going to circle it. And for extra insurance, I know I set these earlier, but I'm just going to set them again here. Oh, except bugdir. I want to keep bugdir because I wanted to try keep going in that direction first. Okay. So now we have the 0 state. So else. So first we know that if we are in the location that's closest to the obstacle, then that's closest to the target, we want to keep heading there. So we're going to say if rc.getLocation equals it was called closest obstacle, then we want to set bug state to 1 again, bug state to 0 again. 0 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 to 0 And then we want to make all the updates necessary to closest obstacle and closest obstacle distance. So if rc.getLocation dot distance square to destination, and this is less than closest obstacle dist, then we set closest obstacle dist to this value right here. And then we set closest obstacle to rc.getLocation. Because now when we come back to this location the next time, we want to head straight for the target. So finally we get to the part where we circle the target. So we do if we do a for loop again, the for into I is equal to 0, I is less than 8, and then I plus plus. Oh, okay. C dot can move bugdir. What we want to do is rc dot move. Yeah. And then we want to rc dot like bugdir is equal to bugdir dot rotate right. And the reason we want to do this is that if we are coming across a right corner, we want it to turn right and keep going to follow it. We don't want it to keep going straight forward. And then finally we want to break, because once we've done this, then we're done. We don't want it to keep doing anything else. So here, otherwise we're going to set bugdir to bugdir.rotate left, because that means that there's something ahead of us. We want to keep trying to go left and see if we can go forward. And this is our bug 1. Does anyone have any questions about the implementation? Okay, so this is the lecture robot player, yes. So here we clearly had bugnav 0, so now we can change it to bugnav 1. Okay. And we also might want to add, if RC is not spawned, we want to like reset. Now RC is spawned. We just want to do some resetting, pathfind reset bug. Yeah, that way when it's dead, it will not try to use the previous values from when it was alive. Okay, and let's see how this one does now. Here we have the 2 lecture players, and we're going to run this game. You can see this one heads straight for there, and then starts going left and starts heading towards the crumb in the center there. And you can just see right there, it overshot a little bit when it made one of the turns. So we're going to talk about that in a second too. You can see here it's continuing to overshoot a bit. You can see it's going around the second time. And if you're wondering what the white duck is doing, the white duck is also trying to get to 6-6. And it got to the closest location it got here. But the white duck is also trying to get to 6-6. So because there's a giant wall here, it's just constantly going around the entire perimeter. So that might be something you want to think about when you do a bug nav. So you probably noticed earlier that it was overshooting at some of the turns. And there is a way you can fix this, although this may lead to other issues. But yeah, the way that you can fix this is if you go to Pathfind, you just add a second bugdir.rotate right. So every time it rotates 90 degrees right instead of only 45 degrees. And if you do this, you have to increase this to 9, because otherwise it won't go through all 8 cardinal directions. And then if we do this, we should see that it stops rotating it stops overshooting when it like makes some of the turns. And you'll notice that bug 1 right now, it's taking a longer time to reach the target, but it also has a guarantee that it will reach the target, unlike bug 0, which reaches it faster in often a lot of cases, but also could lead to an eternal loop, which is not what you want. Maybe you could think of some possible trade-offs between the two, like maybe using bug 0, but then if you notice you keep coming back to the same place, then you switch into trying to use bug 1. So you can see now when it reaches the corner that's previously overshooting at, it just goes cleanly across it. And this is the bug 1 implementation. Does anyone have any questions before we move on to bug 2? Because it gets a bit more complicated from here. No? Okay.
All right, so as you might have seen with bug one, it is guaranteed to let you reach your destination as long as it is reachable. But it tends to generate some pretty long paths because you have to circle around like the entire obstacle to find the closest point on the obstacle and then weave and go towards the location. So I'm going to show you how to make a different algorithm called bug two that is fairly similar, but is a little bit smarter and will lead to some shorter paths to the destination. So essentially for bug two, we have the same idea of like going around obstacles in the left direction. But instead of going all the way around and trying to find the closest location, we draw this line starting at your start point and going to the destination. And then every time you encounter an obstacle, you keep going around the obstacle to the left until you run into that line again. And specifically, if you run into that line at a location that's closer to the destination than where you originally were. So like in this example, we go around here, we run into the line again, and then it goes to the next obstacle and does that again. So I'm going to walk you guys through how to implement that. Where is VS Code? There it is. Okay, so the first part of this algorithm is basically drawing a line that goes from the starting location to the destination. And that part's honestly a little bit confusing, to be honest. I just looked up how to convert a line to like grid squares because I didn't want to figure it out myself. And I'm not going to walk through like all the implementation details of that. But if you just look up like how to convert a line to squares on a grid, then you'll end up with basically this algorithm. So yeah, I'm just going to copy this into our file. Again, it takes in a start, it takes in a destination, and then it's going to give us a set of all of the map locations that are on the line from that start to the destination, just like the straight line. So copy that and go ahead and put it into our pathfinding file. And we've got some issues here because of imports, so let me just deal with that. So we need a hash map. We also need application, which I'll put, oh, that's already there. Maybe this fixed it. Yeah, okay, looks good. Okay, so now we have this method that lets us generate a line of grid squares with a start and end location. So now we're ready to go ahead and start implementing BugNav2. So I'll just put it right here. And actually, I think it will probably be easiest if I just copy BugNav1 because a lot of it is similar. And we'll go ahead and change the parts that we need to. So just copy this. And here is our BugNav2. So again, we're going to need some new pieces of state here like we did for BugNav1. It's slightly different this time. So one thing we're going to need is we're going to want, first of all, a map to store all the locations on the line, since we can just compute that once when we start pathfinding to a new destination, and we won't ever have to compute it again. So I'm going to make a hash map of applications called line, and originally that's just going to be equal to null. Why doesn't it like my hash map? Oh, sorry, hash set. Yeah, this should be hash set too. So used to making hash maps, got hash set was a thing. Okay, so we have our line, and then we're going to need two more variables. We're going to need a variable to keep track of the distance we were from the destination when we first started going around an obstacle. So we're just going to call it like obstacle start distance. So as soon as we run into an obstacle, we'll set this value, and then we'll only leave the obstacle when we intersect the line at a location that is closer to the destination than this location. So we can also just start off with this being null. Or this is the distance. So we'll set this to just 0 for now. And then we're also going to want another variable to keep track of, okay, it will become apparent why we need this in a second, but for now, I'm just gonna make Southern application called previous destination. And basically the purpose of this is if we change to a new destination, we're gonna have to recompute that line that we're following. So that's what we need this variable. Okay, so that's all the state that we need.
You set the distance to a map location instead of an int.
Oh, yes, that would be a problem. Would be an int. All right, looks good. Okay, so now let's go ahead and implement bugnav2. So here it is. Okay, so the first thing we're gonna do is we're gonna check if we've already computed that line that we're gonna follow, like that straight line from the start to the destination. So we're gonna check if our destination is not equal to the previous destination. And that means that maybe we were trying to pathfind to some other location, and now we changed it to a new location, and in that case, we need to update our previous destination. So we'll say prev_dest equals destination. And then we want to recompute that line that we're following. So we say line equals, and then we're going to call that method that I pasted in. And we're going to create a line from our current location to the destination location. Also, just like for debugging purposes, I don't know if you guys have been using like the indicator lines and dots, but those can be super helpful. So another thing I'm going to do is I'm going to put dots on all of the squares that are on this line so we can get a better idea of how the algorithm is working when we go to visualize it. So let's just loop through all the map locations on the line. And then for each one, we'll make an indicator dot at that location and we'll just make it red, 255.00. Okay, so now we're just going to make a few changes here to implement bugnav2. Again, it's going to be pretty similar to the idea with bugnav1. So I think this looks good. This also looks good. So here I called my variable something slightly different. So instead of this, I believe we need obstacle start distance equals, and then we want to record our current distance from the destination. So we'll just do get location dot distance squared to destination. And then let's just make sure that's everything. Did I delete the direction? I think I did. Plugdir equals get the direction to the destination. And I think that should be it. We no longer need closest obstacle. That was part of bugnav1. Okay, that looks good. So yeah, if we run into an obstacle, all we do is we record the distance from that obstacle to the destination. And then once we're in like the navigating around an obstacle state, which is state 1, then let's see, what are we going to do? We want to check, first of all, if the location that we're at is on the line, and if the location is closer than the previous location when we intersected the line. So we'll say if line dot contains, this is like the method in Java for checking if something is in a set. And this should be like super efficient. We compute the set ahead of time that has all the locations on the line. And then it should be very fast to check for any given location if that location is on the line. So we just say if the set contains our current location and our distance is less than the previous distance when we were on the line. So we say and rc dot get location distance squared to our destination is less than obstacle start distance. And if that is the case, that means that we ran into the line again, closer to the destination. So we're ready to go back to bug state 0 and just start going directly towards the line. So this is like our new algorithm for determining when we can leave the obstacle. It replaces this code, so we can go ahead and get rid of that. Okay. And I believe the rest of this should be the same. We don't need this anymore. Because again, this was, yeah, for keeping track of which location on the obstacle was closest. It's part of bugnav1, so we can get rid of that.
Before you run it, I think there's an error there's probably an error at the end of the box, probably like a missing close parentheses somewhere.
Probably, let's see. What is that? something odd happened, but that should be why. There you go. It was like the first part of like git checkout or something. I don't even know.
Yeah.
Okay. I believe this should be good. So let's go ahead and test it out. So first I gotta go back to robot player and replace plug nav one with plug nav two and get rid of that. Okay. So now let's go ahead and visualize our game. Where's the client? There it is. Okay, so we have lecture player versus lecture player. We're going to just use the same pathfinding test map, and we're going to go ahead and run our game. Okay. Okay, right off the bat, there's definitely something not right here because it should be drawing our visualization line. I'm not too sure why that would be.
You need to reload map from players because it hasn't like saved yet or something.
Yes, thank you. It is not. Yeah,
Oh,
there we go. Yeah, looks good. Thank you. You saved me a lot of trouble there. Okay, so let's go ahead and visualize our game. We can see it's following the line. It runs into the obstacle and it's going to start going around. It should keep going until it gets here again. And then when it does, it sees it intersects the line and then it goes directly along the line to its destination. This poor white duck here is still just horribly confused and it's going to wander around forever, but you can see that it worked as intended here. So yeah, that's plug nav 2. Do you guys have any questions about how that implementation worked? All right, cool. Where did the slides go? Yeah, that's pretty much all we have. Thank you for coming to our pathfinding lecture. Yay.
yeah, feel free to stick around for office hours if you need any help on your bot, on pathfinding, anything in general.